Hey there, my name is Rohit Kumar, and today we are going to discuss another important dataset named ModelNet. So in today's video, we are going to discuss multiple aspects of ModelNet, the kind of applications, the kind of works which have been published using ModelNet, and the other references. Additionally, the original work which introduced the concept of ModelNet. So let's start, and we'll begin with the basic definition of the ModelNet so that the new users don't get confused with that about what actually is ModelNet and how specifically we are going to use it. So here it is. You can see that we are landed on the page, means the home page of the ModelNet. And this ModelNet homepage consists of multiple things. Like they have discussed the kind of goal, what they had in their mind while designing this particular dataset. Additionally, they have given the 10 class orientation aligned subset download, then the 40 class subset download they have provided. Then they have the aligned 40 class subset. So it means that based on the specific requirement, the kind of pre-processing which many people do at their side, for example, they don't have given this particular kind of thing, then you can get the original ModelNet and then you can do it at your own side. So it depends, means you can create your own subsets of a specific particular data set that is given. But all that you need to do is just to simply take the reference of the original data set and just to give the credit to the original authors. So here, if I show you, then it is the main work that is given over here. 3D shape nets, a deep representation for polymetric shapes. So here the citation information and everything is given over here. Additionally, if you want to get the kind of oral presentation related thing, then their related web page link is also given over here. Okay, so you can go there and you can find. This work was published in the 28th IEEE Conference of Computer Vision and Pattern Recognition, CVPR 2015, one of the top-notch conference. And you must have heard about this, that the quality of work and all those things are published in CVPR. So that's why means you should go. And additionally, wherever you land on this particular page, you just need to go through these papers also. So you can see that n number of papers they have listed down here 63, but I do believe that these are only up to 2019. So there are multi more, and especially as we are in this particular era where the research is going exponentially. And it's quite obvious because today's time is dependent on the research data, research efforts, sort of things, just to boom the kind of things we are having in the technological domains, because so many different technologies are collaborating together and they are forming the new spaces for research. And that's why the kind of interdisciplinary research is so popular. So if you are interested that this particular data set is being used in a different works, but how specifically it is used, so you can take reference of these papers. And based on your specific interest or your subdomain, you can see, for example, in 3D point cloud classification and segmentation, they have discussed. Then they have discussed the set clustering and pooling. Then they have discussed the deep convolution neural network for 3D. So all these things are provided over here. You just need to align your research area with this particular data set and then you can move further. So that's why you need to see the past works, means the existing literature that guides you in the right direction, that yes, earlier the authors have done like this, so you can also do like this, because research is always incremental. So just exploit that specific feature of research and doesn't matter whether you are doing the application research or the basic research. Most of the time we go incremental. So here, when you are here at this particular page, so you will find a lot more information, including these specific things that I have told you. Then you have the ModelNet benchmark ledger board. So many times, hope you understand the meaning of benchmark ledger board. So the kind of examples that they have given. So they have given here different sorts of description. And you can see the number of algorithms that they have given over here with respective references. And these references come from these references only. Okay. So there they have compared based on the ModelNet 40 classification, the kind of accuracy they are giving, then MF. Then they are giving the accuracy with respect to ModelNet 10 classification as well as the retrieval also. So this is for this particular data set, the kind of basic information. Additionally, I will recommend that you go to different websites and different scholarly web pages where you find the additional information about the datasets and the kind of works which use ModelNet. So particularly, if I tell you, then ModelNet 40 in short, if I say, then this dataset contains the synthetic object point clouds, and it's a kind of the most widely used benchmarks for point cloud analysis. So ModelNet 40 is kind of popular for kind of various categories, including clean shapes, the very structured data sets, etc. And so many different point cloud data points are uniformly sampled from the mesh surfaces usually. So they have discussed that they usually pre-process by moving the origin and the scaling into a unit square. So means these sort of things means you don't need to go into details. You just simply land onto the ModelNet page, download it, and see the specific exploration, the kind of work people have done with ModelNet, and then you will understand that how specifically you are supposed to pre-process it, use it, and enhance it further. Additionally, if you need any additional information, you may contact the authors also. Coming to the specific discussion of benchmarks, so there are multiple tasks that you can do with this particular dataset. You have the kind of 3D point cloud classification with respect to specific few shots. So the number of shots might vary. It might be 10, 20, etc. And multiple models also there, which you can find like point to vector, then point view GCN, Recon, etc. And coming to the specific works, if I tell you, the number of works are there. Additionally, in 2020, there was a work published like the energy-based processes for exchangeable data. So that particular work discussed about the specific energy processes. And there was another work published in 2021 where the implicit PDF named non-parametric representation of probability distribution on the rotation manifold is discussed. So these sort of works are available, and respective GitHub implementation is also available at the GitHub page. So you just need to move on to the GitHub, and there you can have the specific implementation. There you have the specific PyTorch related and different libraries also to assist you. So many times, including the kind of details which is given over the GitHub page, helps you a lot in the actual implementation. So go through that. Coming to the kind of things which people are doing with respect to this particular data set, same things you can do on the related web pages, on the related web data sets also, because there are multiple data sets available and you can access them through net. So the one is there that is called ShapeNet Core. Another one is Scan Object N. Third one is S3DIS. So these are some closely related data sets which are related to this particular data set. And if I tell you, then there are a number of papers published over the years, around more than 100 papers almost published in last 3 to 4 years with respect to this particular data set. So you can see the kind of popularity of this particular data set. Like I told you, different other data sets also like Point Cloud C. So that is also quite widely popular, and hundreds of papers have been published in past few years. Similarly for ShapeNet Core and the Scan Object NM. So just to go and have the specific understanding of a specific data set based on the specific use case, means what is your interest, what you want to do with a particular data set. Additionally, coming to the modality of this particular data set, then 3D and point cloud are the basic specific features. And this particular data set is going to help you in the specific research, like if you are going for the vision and all the sort of related things. So additionally, the 3D point cloud classification is specifically going to help you to develop your own models, having your own variants of data sets, because people have done it earlier. They have specifically gone for the specific subset data set implementation. So if you want to make your own, then you can make, and you can cite the original work only. That's the only basic requirement. Additionally, for the specific contribution or the collaboration related thing, you may contact the authors. There is specific details and the kind of different contact information must be given over there. Here it is the basic address, and in this sorry, not the address, it is the basic details with respect to the cat models and the object category, which specific category you want to focus, and which specific annotation orientation you want to work with. So these things you need to decide, and then you just need to contact with the author. So right now here they have not given any specific and exact details for contact relation, but hopefully you may just find onto this particular paper, just open it, and there you'll find some of the related emails and there. So that's all from my side. Hopefully you must have liked some of the related parts. Some of the things definitely you must have didn't like. So whatever contributions that authors have done over here must be appreciated. With that, you need to explore it further. That's all from my side. If you didn't like anything, please do comment below and criticize this. Will definitely contribute in the coming future videos according to your specific comments. So we'll improve the parts which were not good in this particular video. Thanks for watching. Happy learning.